Welcome to Ask and Learn.
Our goal in this problem is to find the values of A and B. We have this function that relates the population of yeast to A and B, and we have two pieces of information. We know that at time 0, the population is 20, and that at time 0, the rate of change is 12. And so in general, when we're solving for two unknowns, if we have two equations, that's great. So we're going to be able to come up with two equations based on those two pieces of information. So what we can do is we can find the derivative of this function with respect to time, and that will help us use the second piece of information. So f prime of t would be, now first of all, I'm going to rewrite f of t as a times a quantity 1 plus b e to the negative 0.7 t to the negative first power. That way I don't have to use the quotient rule. So a is just a constant, and now we bring down the negative 1 and we raise the outside quantity, or we raise the inside quantity, I should say, to the negative 2 power using the chain rule. And then we multiply by the derivative of the inside, and that's going to be negative 0.7b. Okay, so let's rewrite this derivative. Notice that we have a negative in two places. We have negative a and we have negative 0.7, so negative times negative is positive. So we have 0.7 ab over 1 plus b e to the negative 0.7 t quantity squared. So that is one relationship we have. We have the derivative, and what we know is that the derivative equals 12 when t is 0. So f prime of 0 is 12. So let's go ahead and put 12 in for t and see what happens. 12 equals 0.7 ab over, now we're going to have e raised to the 0 power. And what is e to the 0 power? It's 1. So we're going to have b times 1. So we're going to have 1 plus b quantity squared. Okay, so we're going to take this as our first relationship between a and b. And now we need to get the second relationship between a and b. So we're going to go back to f of 0 equals 20. Going back to the original function, f of 0 would be a over 1 plus b times e to the 0. And again, e to the 0 is 1, so this is just f of 0 equals a over 1 plus b, and that is going to equal 20. So we have a second relationship between a and b. Okay, remember that our goal is to solve for a and b, and there are several directions we could go from here. We could take this equation that we just found, we could isolate a and do a substitution, or we could isolate b and do a substitution. Or, I think this might work out nicely, we could take the entire a over 1 plus b that we see in the other equation and remove it and put a 20 in its place. So let's try that and see what happens. So with the second equation, we have 12 equals 0.7 times 20 times b over the remaining 1 plus b. See, we took out the a over 1 plus b and we replaced it with 20. Now let's solve that for b. So we're going to multiply both sides by 1 plus b, and we get 12 plus 12b equals 14b. And subtract 12b from both sides, we get 12 equals 2b. And then divide by 2, we get b equals 6. Okay, so now if we know that b equals 6, we can find a, because a over 1 plus 6 would be 20. So a over 7 is 20. So multiply both sides by 7, and a is 140. Now if we substitute those numbers into the model, we have the population is 140 over 1 plus 6 times e to the negative 0.7 t. Now what happens, the final question is what happens in the long run, meaning what happens as t goes toward infinity. So let's take the limit and find out. So if t is going toward infinity, then this is like e to the negative infinity, which is very, very close to 0. So 6 times very, very close to 0 is also very, very close to 0. So we basically have 140 divided by 1. So it's heading toward 140. as time goes on.